Okay, so the last transformation that we're going to do is dilation. I think it's the easiest one out of all of them, so hopefully you will too. The definition is changes the size. Okay, this is the only one that changes the size of the shape. It still stays the same shape. You guys have probably heard of dilation like with your eyes. Sometimes you go to the eye doctors and you get your eyes dilated. It makes your pupils bigger. That's where this word comes from. So to define what dilation is being used, we use the scale factor. And the scale factor is represented by the letter K. Why? I don't know. It just is. And this tells us how big or how small the shape is going to get. Okay. So we have a couple situations. If K is greater than 1, so 2, 3, 4, 5, 6, then my shape is going to get bigger. If K is a number in between 0 and 1, so fractions or decimals, let's say, for example, this one, a half. If K is a half, then it's going to get smaller. And this one you don't really ever see, but we're going to talk about it. If K is equal to 1, it's going to stay the same. Okay, go ahead and write down example 1 there. So triangle ABC has been dilated by 2. Find A prime, B prime, C prime. All I have to do is multiply every coordinate by 2. So times 2 times 2 times 2 times 2. So A prime would now be still 0, 0, because that didn't change. B prime would be 16, 0. And C prime would be 6, negative 4. And all I did is take 3 times 2, negative 2 times 2 to make it 4. That's my answer. Okay, write down number 2. On this one, K is 1/2. So I'm multiplying everything by 1/2. Which you don't have to do this every time, but I'm going to. Okay, so really I'm just splitting these in half. So half of 3 is 1.5. Half of 8 is 4. Half of 10 is 5. Half of 6 is 3. Half of 8 is 4. Half of 2 is 1. And that's it. You can also take this like in your calculator as well. 10 times 1/2, and it'll give you 5. On your homework, you have some crazy fractions that aren't as easy as 1/2. So you're going to want a calculator that multiplies fractions to help you out. Okay, of course, we have to have a graphing one. So go ahead and write down example 3. Okay, I'm going to graph these original points. And label them. Okay, so now dilate with a scale factor of 3. So F prime is not at negative 1, 1. It's now going to be at negative 3, 3, because I'm just multiplying by 3. I'm going to go ahead and do all of these, and then I'll graph them. That would now be 3, 3, because I'm multiplying by 3. To negative 1, that would be 6, negative 3. and then -3, -3. Okay, so now grab all of those. Don't forget to label them with your prime symbol. Okay, and there's your graph. Someone in class today said, wow, that's like 10 times bigger. I said, no, really, it's 3 times bigger. So it is bigger, yes, but not 10 times bigger. All right, last one. It's kind of a word problem. Write that down. Okay, so we're kind of working backwards to find the scale factor. If we're multiplying on all of our examples, whenever we know the scale factor, if we work backwards, what do you think we're going to do to find the scale factor? We're going to divide. So here's kind of the rule of thumb when dividing. You're going to take your new number on top and your original number on the bottom. So whenever I'm looking at this problem, let's just look at the 3. That's the width of my picture. Then what's the width of this one down here? Be 7.5. I can just look at those two numbers and that'll tell me the scale factor. Which one goes on top? The new one. So 7.5 would go on top, 3 would go on bottom. So then get your calculator. Going to do 7.5 divided by 3, and I get 2.5. So my scale factor is 2.5. I enlarged it by 2.5 inches, units, whatever it is. Okay, that is it.